Hello, so today I'm looking at M3 International A-Level January 2016. This is question 1. So I'm given a hemispherical bowl of internal radius 2r is fixed with its circular rim horizontal. A particle P is moving in a horizontal circle of radius r on the smooth inner surface of the bowl as shown in figure 1. Particle P is moving with constant angular speed omega. Show that omega is this. So remember, in a show that question, you cannot use this. And the question is basically asking you, what is omega? By the way, this is what you should get. So if we begin by drawing a diagram of what's happening to the forces on the particle and the distances that we know. So I know that the distance from the particle to the center of the circle, the horizontal circle that it's following, is r, and I also know that the distance from O to P is 2r because it takes you from the surface of the hemisphere to the center of the hemisphere. So my center of the hemisphere is O, so I just put a little O up there to help myself understand what's what. And so the particle is here. We also know that the particle is moving in a horizontal circle, so therefore there will be an acceleration towards the center of that circle, which will be, I can use v squared over r, or I can use r omega squared. Now in this case, as I'm being asked about omega, I shall use this for the acceleration and not this one. So the radius of this circle is indeed r, so I can write r and omega squared. Now I need to get an equation with omega in it, so I could resolve towards the center of the circle. That will also give me r and theta, so it would be a good idea to first try and get an expression for r and for theta. So if we try, here I've got the adjacent and the hypotenuse, so that would mean that cos theta is the adjacent divided by the hypotenuse, and that would give me a half, and therefore sine theta would be root 3 over 2. And if I resolve vertically, then I get that r sine theta is mg, doing forces up equal forces down, because in that direction it's not accelerating. And sine theta, I said, was root 3 over 2. So therefore root 3 over 2 times r is mg, so therefore r will be 2mg over root 3. I won't bother rationalising this yet because I need to see what else I'm going to get, and hopefully that will cancel out, or perhaps not actually, because I need that root 3, but anyway. So to get an equation with omega in, I can resolve towards the centre of the circle. So this time I have r cos theta equals the mass times the acceleration, and I know that r is this thing, so I have 2m, so I'll start just a bit lower, 2mg over root 3. That's r multiplied by cos theta. Cos theta I worked out to be a half, is equal to mr omega squared. So I can see that the m's cancel, I can see that these 2's cancel, I can see that in order to get what they wanted, I need a root 3 on the top and a 3 on the bottom. So I can multiply top and bottom of this by root 3. Now it's getting a bit of a mess, so let's just rewrite this again. So here I get omega squared, I'll divide by r, I've got g over root 3r. And now I can multiply the top and bottom of this by root 3, so I'm essentially multiplying by 1 and therefore not changing its value. And so here I get g times root 3 over 3r, and that would be omega squared, so therefore omega will be the square root of this. And fortunately that is the same as what they wanted me to show here, so as required. So there you have 6 marks. So I hope you found this solution helpful. Do click like if you liked it, and good luck with your studies.